I am Ahmed Lashin, Lead Application Engineering Center Innovation. I'll be doing the webinar for Weldments Structures System today. We will go through several topics today about the new structure system, what's a library structure, and how we can use the structure system. And also we will cover advanced assembly topic about smart component because it will be useful as well with the structure system. Then we'll go through Q&A, but feel free to ask me question anytime during the session. Sometimes the question is related to the topic I'm covering, and I prefer to cover it on the fly. Yeah, so let's start. So I'll switch now to SolidWorks. I don't know if any one of you are aware about structure system, the new Weldment features that is available since 2018 in SolidWorks. This tools is available here in the toolbar under a tab called Structure System, and this is the topics that we will focus on today. A structure system is a new developed features from the Weldment features. Weldment features will remain as it is for a long time, but the structure system is just a new developed feature out of it. I will go through the structure system and how can we create a very complex model like this. Keep in mind that if you are using a version of SolidWorks before 2018, you will not be able to use this feature because the structure system is a new feature in, I believe, in 2019. Sorry. Yeah. So I will start now by opening the library files for structure system. If you are aware about Weldment features, you know that the Weldment features is using a library files that you have to download from SolidWorks resources to be able to use it. Usually the Weldment library files structure is folder structure. So when you open ANSI Eng or ANSI Metric or Australian Standard, when you open the folder, you will find a folder for each and every type of structure member, RHS, C member, and everything here as a folders. When you open a folder, you will find there is a file for each and every profile size. This is the old style or the old structure of Weldment profiles. It's a little bit pain because if you would like to create a customized Weldment profiles, you have to create a file for each and every size, which consume a lot of time and effort, especially if you have to do any modification. You have to modify all individual files one by one. Recently, Weldment features, the regular Weldment features now is supporting a configured Weldment profiles. The configured Weldment profile folder structure is a little bit different. All you have to do is folder for each and every standard, and inside the standard, you will have only one file for the profile type. Inside this one file, like let me show you the RHS. It's just one single file, but with a design table for all the sizes of this type. Definitely I can't open it by double click, I have to drag it inside SolidWorks. So just single file for the RHS type, but inside the single file, there is a configuration for each and every available size for this type, which is really easy to modify. So all you have to do if you would like to modify the profile custom property or some dimensions in the profiles, you have just to modify the design table. I will show you now editing the table so you can see a list of all the sizes. So it's basically an Excel file inside SolidWorks that allow you to add additional configurations or additional sizes or customize a custom property or a size for existing configuration. So this approach of library files is applicable for the regular Weldment features as well. So from now on, you can switch to this library files and use it. The configured library files is not yet available by SolidWorks team. We have a list of the standards, but it's a user-based library, so we're still investigating it before we publish it in MyInterCAD. I believe all of you are aware how you can find the Weldment profiles in MyInterCAD or not? Anyone aware about MyInterCAD? I have a question here from Steven. Is this webinar similar to the 2020 demo you did in Nelson a month ago? The one I did in Nelson was just showing capabilities in a short time. So what I will do now is I will spend longer time covering more about the structure system tools. I will use the same model and other model as well, but I will cover it in details so you can see the model capabilities. Yes, Steven. Yeah. So if you have my InterCAD application installed, my InterCAD is basically an add-on created by us, by Center Innovation, to allow you easily to communicate with the support team and to access all of the webinars that we do, and also to access any library items that we share with our customers as well. So for example, in my InterCAD interface, there is an icon here for My Toolkit. When you double click in My Toolkit, you will find a list of all the files that you can download that will help you during the design process. For example, for Weldment profile, you will find a list of all the Weldment profiles that you might need. One steel, for example, is one that has flat bars and some kind of members that is not available in the standard library. And you can see here the AS Australian members and all the standards is available here. We will publish here the configured feature once it's ready, so you can download it from my InterCAD directly. Someone mic is on. Yep, all right. This is good. So what I went through now is covering how Weldment profile structure is. So this Weldment profile new structure or new type, which is a configured type, is applicable to use in the old Weldment features. But for structure system, you are only allowed to use the configured version. You can't use the old version of the library files anymore with the structure system command. So if you start using structure system, please download this configured features to be able to use it. All right, so now I will switch to, just a moment, to my SolidWorks. Okay, so I'm using my other screen now, and yep. So I will start a model from scratch using a structure system. And I'll build all of the features with you to show you how structure system is more powerful than Weldments. So as you know, in Weldment, when you build the several members, the concept is you have to select a group of members in parallel or series. And if you have to modify a particular member, part of a group after you create it, you have to edit the structure member feature, exclude this member from the group, then create a new Weldment feature for this particular member. So modification for the Weldment feature was a little bit pain, and even the creation because of the rule of a series selection or a parallel selection for members. So now I will show you. Let me start by the model for 2020. So I will cover two models today, one for the 2020 and another one for 2019 as well. Yep. Okay, this file is not loading, just a moment. Okay. Yep, it's loading here. So in the regular Weldment features, if you would like to build members, you have to have sketches represent the member location. But for a structure member, you don't have to use only sketches. You can use surfaces, you can use planes, you can use a combination of all of them plus references like axis and so on. In the structure member tab, there is three main commands. Structure system to start the structure system modeling. Once you turn it on, now you are ready to build the primary member or secondary member. Once you are done, all you have to do is just to close the structure system so you can finalize it and go to the next feature if you have to build a connection or any additional feature later on. So it's like starting structural system mode, then turn it off once you are done. Then next step is the starting a primary member. Starting a primary member will show you several options here to build a structure member. It could be either a path segment member, so you can select a group of lines or points. So this one is using a sketch lines. Second option is reference plane members, so you can use a planes and axes to create a members. Third option is point length members, so you can pick points to create a members between them. And the fourth option is connecting surfaces together. So if you have intersecting surfaces models, which you will see in the next example, you can use it to create member on the intersection between the surface faces or surfaces. So for this example, I will use points. Show you here that we can use point connected together to create members. But before I start selecting elements here, I have to define the profile first to be able to see a result. In the profile, I have a list of all the profiles that I have in my folder. To have this list here, you have to define the option file location Weldment profile. So you have to add here your Weldment profile folder. Yep. Which is the configured one that I covered earlier at the beginning of the webinar. So we have a full list here of all the members. I will select the CHFT profile. I will select the type to be W section, and I will select this one. Yeah. All right. So after I define the profile I will use for the next selection, I will switch to member tab. And member, again, you have 4 options. You have to specify which option you will follow. So I will follow the options for points. And in points, you can just pick 2 points here, and this will create a member between them. Or you can, sorry, this one. Yeah, it could be a point, select a point, reference point, or vertices. But in this case, I'm not defining the end condition by a length, because if I pick a point, all I have to do is define a length. All right. So by default, this option is adding a length based on your definition. So you can add like 500 based on point selection. Or instead of defining the length perpendicular to the point, you can define any other end condition. So it could be point up to a particular point. So I'll pick another point here. If you would like the end series or the members to be a continuous member based on your selection, we have an option here called link, or I don't know why it doesn't show the name, but this one is creating a link between a series selection. So in this case, if I pick this as a first point, this one will be the second point, then the next selection will be a series of members and so on. So you can keep selecting points and create members between the selected points. So what I covered till now is just picking a point and define an end condition to be length or end condition to be another point. End condition could be up to point instead of connecting points. The difference between point and up to point is that if you have 2 points selected here, both of them will be up to a particular point, not connecting together. So point looks like a series of points, but up to point is a reference. All of the points will be up to a particular point. The last end condition here is up to plane. Up to plane is like if you have 2 points selected here, both of them will be creating a member up to a selected plane. For any of these conditions, you usually have an option here to define a direction. Because usually the direction is perpendicular to the sketch plane of the point. If you remember, guys, when we started here by the option length, we defined the length to be 500 or 400. But why the length is in this direction? Because usually the extrusion or the member will be perpendicular to the sketch plane. So the point was sketched in a 2D sketch in the bottom plane or the top plane. That's why it looks perpendicular. But any end condition has a direction of member where you can assign the member to follow this direction, for example. It's applicable to be applied in any end condition, like up to point condition, or sorry, up to plane. You can follow other sketch segments to define the directions of the members. All right, looks good. So I'm done with creating the main members. So I will click OK now. Yep, so if you remember in the old technique of creating member using a structure member command, if we create a structure member combining these two parallel members, if you have to modify one of them, you have to edit the feature, remove this member from the feature, then create a new feature for this member to be with a different size or different type. That's the only way we do modification in the old process. In the new structure system, if you want to modify one of the members, all you have to do is click on the member while structure system command is open. So again, structure system command must be open, then click on the member. Once you do one click, this click automatically will open a command for modifying this member. Behind the scene will be excluded from the group and will assign a different size or different condition. So you can change here the profile to be something else. Yep, and you don't have to worry about features anymore. I have a question here from Epson about what is the split command. Yep, I believe you are referring to, it's not here anymore, but yep, okay, I will answer your question very soon, Epson. All right, so now what I covered is how you can modify a member. Just click on it one click and you will be able to modify the profile type or size or condition. We can start another primary member with any of the four conditions that all of you now aware of, or you can start a secondary member. Secondary member is referring to creating a member based on existing members using one of these two options, either planes intersecting with existing members or between points of members. So you can pick an area of a member here and a point on this member here and connect them together with another member. So I believe you're asking about this split command. Am I right, Epson? Yep. All right. So I will answer this one during the next feature. That's good. So in the second member, I will use this option, which is support plane. So I have to pick all the planes and the members. So the first window here is for defining the primary member. And if you look at the help nodes that appear, it asks you to select a primary member that pair together to generate a secondary member. So you have to select pair of members, not just one single member. So clicking on the first one, then once I click on the second one, both of them will be in one row, member 2, comma, member 1. So that's the two members that we will create intersecting members between them, either using points or using planes. Using planes, all you have to do is just pick planes here that intersect with these two members. So last time when we created the members, we didn't check any commands here. So let's see more details about the start and end and profile. I will start by profile tab. And profile tab, at the beginning here, ask you about the profile in the first section, the profile type and size and standard. You can mirror it. Mirror it means rotate the member. Next section is for the pierce point. So if you would like to define a different pierce point for your profile, look here. The profile has been aligned as the center with the planes that intersect with the two members. So if you would like to define a different pierce point or different connection point, just pick it here. And this will be applied as, yeah, this will be the area of the member intersecting between the plane and the members. You can define an offset pierce point even. So you can give it a particular distance from horizontal. This option wasn't available before in Weldment. Let me switch. So you can give it a particular offset in X and Y direction. Yep. So there's too much flexibility here. Yeah. You can have a profile alignment, so you can give it a different angle, or the alignment could be based on a face or a plane. If you have a surface or face or a plane that defines the angle you would like to align with, you can pick it to define it. Yep. I'll turn it back to 0. I'm happy with this alignment, but still the profile is too big for this area, so I will switch to smaller profile. Usually when you change profile, you have to define the pierce point again. All right, this one makes sense because profile will go inside. Yeah. A split command will not be clear here, so it will be clear in the next member. Because there is no any splitting here can be done. Yeah. Start and end condition, frankly, I didn't try this one before, but we will see it in another one, not in a secondary member. All right. So hopefully this one is clear enough. So I will click OK. Then I will create another secondary member connecting the corner point here with this corner point using a secondary member again. But this time I will use a secondary member. I will use this option between points, not intersecting with planes or support plane member. Between points, I'll pick the first member and the second one. There is no other option other than the location. So, yeah, look here. So when I change the distance, I move the member in a distance from the start point of the main member. Yeah, same here. So, yeah. Okay. Split member will be clear enough here in this session because in this part, because we have here intersection between this member and the other one. So, but to explain it, first of all, I will assign the value here as 0, other 0, not this one. So you have a reverse direction here to reverse the 0 position, either to be in the right side or the left side, and the other one will be 0 as well. Yep, that's good. So next step is defining the alignment of the profile because I need the profile to be 90-degree aligned. Yep, exactly. So instead of creating the member like this, then do the trimming later on manually, you can use a split member command to consider splitting this area in the final stage. So a split member, you will define that you need to split the member you are creating using a reference or using a dimension. Using a reference, you can pick this member to be a splitting tool on the new created member. Or you can pick, instead of reference, you can pick a dimension for splitting, like split the member after 100 millimeter or something. We will try the other option as well. Yep. So I know the result here doesn't show you any splitting, but the splitting will be considered when you finalize the structure member. So you just define what exactly split you need. Then once you close the structure member, all of this will be applied automatically. But I'm not done yet. Again, I want to show you something here about the modification, because this is the most powerful feature here in the structure member, that if you want to modify any member, just click on it one click and assign a different profile or a different size or even a different orientation. So modification for any members is that easy, that you just click on it to modify it. Yeah, so I'm done with the main member. So once you're done with creating the primary and secondary member, to proceed with trimming, all you have to do is just close the structure system or exit the structure system. Once you exit the structure system, a corner management command will pop up, showing you all the existing corners with the available options for trimming, classifying them as simple or two-member corner and complex members, or complex corners, sorry. So I'll start by the simple corners. Simple corners here is highlighted. So we have like 6 corners, and you can define what type of trimming you want to apply for each and every corner here. And you'll be able to see the result in the preview here in the 3D model. So you can do body trimming or you can do planar trimming. Both of them will give us the same result here, because this face doesn't have any deformation with the member. So just connecting with a flat face. So both of them will give us the same result. But planar trim could be applied with 2 options. It could be either first contact plane trim or full contact plane trim. Yeah, this one will not be clear enough here. You can define a gap between them. Yep. I will switch now. So you can click on each and every connection to specify a particular trim condition. So where is this one? Yep, that's number 3. So you can pick a particular corner and assign a certain trim condition. For 2 members, it will show you here that this is the 2 member corner. Obviously, I don't want to have the corner like this, so I'll switch to different option. Yep, this is what I'm looking for. Yep. Looks like this is the only corner that has 2 members. The others has 3. So this one has 3 members and this one has 3 members as well. So any 3-member connection will be considered as complex. So in complex, you will see here all the complex corner. Complex automatically applies the trimming here based on the selection we did in the creation. I will answer your question very soon, Tom. So complex will show you the corners for any 3 members connected in one joint, and you can specify what type of trimming. Automatically, it's been selected here to be with this order, but you can switch order by clicking on the trim order and change it here. So you can see here it's a different result now. Yep. Oops. So switching order is giving us different results. Yep. All right. So that's a different option for trimming this area, and this one as well. It looks like I modified this one. Where is this corner? Oh yeah, this is the corner number 1. No, that's already done correctly. Yep. All right, so all I will do now is I will click OK. And you will see all the trimming has been done here. And this complex corner looks like this. I tried to build something similar like this using the old Weldments features, and it was really complicated. It takes a long time to be able to do such trimming and to build this member easily. Tom, to answer your question, can you modify more than one member at once? Yes, you can. So to answer your question, I will explain what's happening here in the tree now. In the tree, you can see that we have two features. One feature called structure system, which has a grid. This grid created by the structure system command. We didn't build this grid, right? So this grid has been created by the structure system command and has the profile or the members within it as a folders. And there is another folder showing you the corner management. The corner management has all the type of corners, so you can modify any of them by edit feature here. All of these features is editable by right click on the folder and select edit feature. So if you are not happy with a particular corner, you can just right click on the corner itself and edit feature to assign a different corner trimming option. Or you can click on the folder, then right click, edit feature to modify the entire complex corner options. So this is how you modify. So I don't want to modify the trimming. I just want to modify some members. So all you have to do to modify members is just right click on structure system, edit feature. So now you are inside the structure system mode. If you control select group of members, you'll be able to modify all of them in one go. You can control select or you can just do window select, and whatever selected by the window select, you can modify all of them together. So yes, the answer for question is yes, you can modify more than one members in once. Yep. So hopefully the structure of the tree is clear enough. Yep, so let's move forward in finishing the model here. So the next step is building a pattern for this members. Circular pattern around this axis. So the new feature in 2020 is that you can pattern all of the structure members in one click, and instead of defining body per body. Like ideally, you have to select one by one like this. But in 2020, they created a new feature which called structure systems that allow you to select the entire structure system folder to do pattern for in one click instead of selecting one by one. Okay. So I will finalize the model, then I will move to another case study, which will show us more about different options of creating members. So structure system, I will build another structure system to create the connection between these members. So, and this time I'm not creating a primary member, I'm creating a secondary because I'm creating a connection between existing members. So secondary members, if you recall that the different options we have is between planes or between points. Between planes is the one we will follow here. So I will select the two pair, this first pair and this second pair. So I have 4 members selected here. Then I will select the planes. So based on the pair selection, a members will be created between each and every pair. I'll pick the other plane and this one as well. Defining the profile, pierce point again. We can change alignment, but I think this is good enough. Yep. And I will click OK. There is not much here to do other than this, so I will close the structure system to jump in the trimming tool. That's a different type of trim. We have symbol for any two-member connection. Yep. For this symbol members, I prefer to make all of them body trimming to make sure that, yeah, the cutting angle here will be accurate. For the two member, It's basically for two members connecting at the end point. So simple is for two members connecting, one of them at the end point and the second is in middle of or any other location other than the end points. But when it comes to the second tab, two members means two members connected at the end point. Let's try body trim option. Yep, different option with different results. Again, you can specify a certain trimming for a different corners. Yep. All right. I'll switch to complex. Yep. Complex is for any three members connected together. Yeah, I'll just proceed with it as it is. Let's see the result. No, I'm not happy with this member. With this trimming, this one is not good. All the other corner has been trimmed correctly, except one corner. Yep, everything everywhere is fine, but not this one. So let's see where is this corner to modify it. Definitely it's a complex corner. So I will modify here the complex folder. Yep, this is the one. Yeah, so let's see what we can change here in the orders. Maybe this one need to be modified in the previous corner trimming. Yeah, this one need to be modified to be not like this. Yeah, this is better. So modifying these two corners to be body trim and planar trim and to be full contact planar trim is way better. Yep, fixed the issue, but the other one is not fixed. Because this member as well need to have this condition. Does it? No. Yep, it should be this condition. Hopefully I'm not messing around with the other one as well. Yep, all looks fine now. So any question till now, guys? So I will not proceed with the circular pattern because it's the same as the one I did before. So I'll move forward now to another case. So I have a question from Epson. Can you do an FE on it? Yes, you can. So a structure member is the same as the Weldment profiles. You can use it for finite element analysis using the simulation, and all of these members will be treated as a beam element. So yes, the answer for your question, you can do FEA on it, but not simulation express. You have to have simulation standard to be able to apply a beam element because simulation express doesn't have a beam element option and doesn't support multi-body. Yeah. Any other question? No worries. All right. So I'll move to the next case then. All right. So the next case is a little bit different in the fact of how we started the structure member. So last time when we started the structure members, we used combination of planes, sketch, and points, and axis as well. But in this structure member, we will use surfaces instead of sketches or planes. So we have here a sketch, a hexagonal sketch, two hexagonals, and both of them extruded as a surface extrude. Surface extrudes, I explained it before in the surface webinar. It's like almost a zero thickness sheet which has no weight. We use it as like a supportive tool to create a solid body or for any assistant or a hyper modeling techniques. So we create here a surfaces and now the outer surface as well, which is a little bit shorter than the other one, and a sketch for the secondary members that will connect them together. Yep. So this time I will show you a structure system for group select. So I will start a structure system. I will hide the existing sketch. Should hide it before I start, but anyway. Yep. And I will start a primary member. The primary member I want to apply here is a profile that, no, not W section, should be tube rectangular. I don't remember exactly what size it should be to be in a good shape. Just a moment. Yep, let's go with square. It was a square, I believe. Tube square, yes. 10 by 10. Yes, this is the one. All right. So I want to create a tube square for all of the edges of the surfaces, even the intersecting edge, not only the end edges, all the edges of the surface. So all you have to do is just window select. But before I do the window select, I have to make sure first that I'm using the proper options, that pass segment or member. Oh, yep, done. You don't have to worry about series or parallel selection or anything. Just window select and you created all the members. We don't have to worry about the corner now because this is as you know now, this is the next step after you close the structure member command. Yep, so I'll click OK. Let's say that we have to modify all the vertical members to be round instead of square. So as I covered for the question of Tom, for modifying a group of members, all you have to do is just window select the members, then define a different member type or size. So this time I will select it to be round tube. Come on, I want to follow the same sizes, so just a moment. Okay. So this one, it will be round, and I will assign the size to be, yes, this one. Done. So next step is creating the secondary member for the sketch lines that we hide early. So I will show the sketch. Yep. And I will use, actually it's a primary member, not a secondary. It's a primary member. You can do window select. If you wanna do window select while other member exists, you can use F5. F5 is the filter, so you can only filter for sketches. Why I'm unable to disable everything and only filter on sketch segments. I believe there is an easier way to deselect everything, but I'll do it this way for now. Definitely there is a shortcut to only filter for sketches. So I will do window select. All the sketch line has been selected now. You can assign different profile. This time it will be round, but it will be a little bit smaller. So I will assign it to be the size, tube 7 outer diameter. So this exercise is just like practicing what we did early and the last one, but we can see here more features in the selection, how easy it is to group select members to modify or to create. All right, let's create another complex one. Like let's say we want to use top plane and this plane to create a member for connecting the vertical tubes together and the intersection with the plane, mainly for the inner structural members, not the outer. The outer is already has a connection here. So I'll use the secondary member using top plane, up, yep, define plane, using top plane and using this plane for all the round members in the inner loop. Oops. Okay, so the issue now was this process that I'm not only creating members between pairs. I want to create member between all the selections I will do, not between pairs. So I will clear the selection, and in this case, you have to select toggle a chain selection. So it will be a chain loop, not a pair members only. So when I start selection, now it will proceed with the chain loop. The profile for this loop should be what? Or round? No, it should be square, and it should be okay. So same as the other member or the main members as well. So it should be square and 10 by 10 by 5 by 0.5. Done. Still, we didn't do anything with corner trimming because you are aware now when we close the structure system, we'll proceed with the corner trimming. Yep. So any question till now, guys? I believe all of you now aware about the next step of trimming and patterning and so on. But I want to focus now on another topic because if you are working in an area of a structure member, your main hassle will be creating the connection between the members. So in case of it's not all of them welded together and you have like kind of a connection like a plate connection with bolts, nuts and washers, and you want to apply all of it and to have an accurate bill of material and so on, this will be a little bit the main struggling that you have to create a sketch in each and every corner, do patterning and linear pattern for these corners and build the gussets and add the fasteners and so on, which is really time consuming. That's why I will switch now to another topic, which could be very useful in building a structure member: smart components. A smart component basically is converting a library item to be smart enough to insert other component and other features automatically during the creation of the feature. I'll show you more in the next case. But before I switch to smart component, please let me know if you have any question about the structure system. And I will prepare the other case study until I get the questions from you guys. Hopefully no questions means it's clear enough. That's the other meaning. Yep. All right. I'll proceed now with the smart component. Okay. When you pattern the angular bracing, do the holes in the upright bolt pattern as well? It's a really interesting question. So, what holes are you referring to? Are you referring to the trimming or I get your point. So there is no here holes, CAD. So CAD asking me a question here. When you pattern the angular bracing, do the holes in the upright bolts pattern as well? So let me show you here. So there is no holes here between the members. It just trimmed, so there is no cutting hole. But if you have a cutting hole and you want to include it in the pattern, um, I believe you have to do either two features or one. Yeah, you have to do two patterns. So you will do pattern for the body, then another pattern for the cutouts, which you created manually, because any holes here must be created manually. Trimming will not create a hole for you. Does this answer your question, Kadi? All right. Yep. Good. Yeah. Right. So, um, next topic will be the smart component. Looks like I already did it before. That's too bad. All right. So just a moment, I'm clearing my model because I covered it before, so all the smart stuff is already applied. So I'll clear it. Yep. And I'll clear this cutout as well. Good. All right. So what's a smart component is? I will explain it in this small little box, showing you that you can convert one component to be smart. So once you insert this component in other assembly, automatically this component will insert the other components like the key and the latch and will do the cutouts automatically. So I have this part smart. I can see an icon here of a spark on the part. This means it's a smart component in my library. So I will show you how we can use it in another assembly. So I will copy the part. I will switch to other assembly. I will open another assembly I have here, which is a test assembly. And it seems I did it before as well. So just a moment, I'll clear some stuff from here. Yep, all right. So, and I will insert it again. I will insert the same component here. So I'll just do Control V. So I have my part here inserted. I will mate the latch with this face. Coincident. Oops, the other side. And I will do a width mate now. Oh, come on. All right. Mate, width mate, applied, done. I will not do the other mate. I'll just place a part here in this position for now. So once you insert the smart component in your assembly, all you have to do is just right click on the smart component and select insert smart features. Insert smart feature will grab all of the component attached to it and the features as well to this assembly. But to apply this smart features, SolidWorks will show you a comparison between the original model and the assembly you currently have, asking you to compare the references. So in the original model, when you created this latch, you did a cutout on this face. So SolidWorks is asking you, where is a similar face to this one? So this is a similar face. Then, which is the face is equivalent to this face, side face, where we have the cutout for the key and inserted the key and the key latch? This is the one. So after you do the comparison and define the references, all you have to do is just click OK to insert it. Uh, I don't know why it comes on the space like this. So anyway, as you see here, all the component has been inserted and the cutout as well. There is some issue here, just the component was not attached with a proper mates in the original model. That's why it's not connected. But as you see, once I drag this part, all the cutouts moves with it. The key and this part should move as well. But yeah, but I believe you guys understand the concept of smart component. A library component will insert other components and cutouts once you insert it. I will show you now how you can build a smart component, and hopefully you will not have this issue once we create a new one. So I'll close this test assembly without saving. Yep, that's good. don't save. Then I'll move back to the my master model for the library component. All right, so now I will use this latch part to convert it to be a smart component. To convert this part to be smart component, first of all, I have to do the cutouts and insert the other parts related to it. So the cutout should be in this part. So I will right click edit feature, sorry, edit part, and I will create a cutout in context with the latch. So I will sketch on this face, and I will sketch a rectangular. Keep in mind that such a sketch is not applicable for a smart component, because when we use a smart component and we would like to have a cutout once we inserted another assembly, this cutout could be in a vertical position or a horizontal position or a different position based on the other assembly. So you can't have the sketch have horizontal or a vertical relation, because you will use it in a different orientation when you start use it as a smart component. So please don't use any constraint that has horizontal or vertical. Otherwise, you will be restricted only to insert it in this position once you start using it. So don't ever use horizontal and vertical. You can use parallel instead. Like this two lines is parallel and this two is parallel. We might need to define another constraint attaching to this corner point. Yeah. Or this edge and this line to be collinear. Yep. And here as well. I'm trying to pick the edge, this edge and this line to be collinear. Yep. Good enough. So now my sketch is fully defined without any constraints that would prevent it from being in a different orientation. So I'll proceed in doing my extrude cut feature. And you can define a condition for extrude cut to be up to point, up to vertex, and be connected to the vertex of the latch, or it could be just in a particular distance. So I will do it here in extrude cut with just a distance. All right, that's good. Next step is inserting a toolbox component. I don't know why my library is a little bit wide like this. Yep. So I'll insert a toolbox component to be attached to my latch. Unsymmetric. Yeah, bolt. Let's see. Yep, this one's good. So I will drag and drop in the hole. Oh, sorry, I'm in edit mode now, so I have to exit the edit mode. So I will drag and drop the bolt again. Done. And I'm happy with the size, and I'll insert this one as well. All right. So I have my library part prepared, ready to be converted to be a smart component. To assign this part after you create the features to be a smart component, you can search for a command called smart component, make a smart component. If you want to know where it is, you can click on the eye and SolidWorks will show you the location of the command somewhere here in this tree. So I will use smart component, make a smart component command. Make a smart component, you have to identify where is the main component that will be smart, the latch, which component will be attached to the two bolts, and which feature will be attached to. The feature will be attached to the latch is the cutout I did. So you can attach features and component. Okay. Make a smart component will add a spark icon on this part. So you will see here that this part now became a smart component. I will save my assembly now, my library assembly. Then I will switch to other assembly to test my smart component features. All right. So I'll grab the latch from here, I will copy it, or I will even insert it with just insert component, Control V. Yep, I will do the mates. This two faces is coincident. Usually it happens when I'm in a remote, in a GoToMeeting or webinar, that the interface doesn't show me the quick mate toolbar. Yeah, I will rotate my model, make this face and this one in a distance, flipping the distance to be 1 inch. All right. So once you insert your connection or your component in place, just right click on the component and insert smart features. Insert smart feature will do the comparison, will ask you for all the references you used for creating your model. So if you remember when we created the sketch, we just used this face only to start the sketch. We didn't create any reference or a dimension or any constraint with other edges or faces. That's why SolidWorks is asking me for one reference only, this one. And we did the cutout with vertical, without vertical and horizontal constraints. That's why we are able to flip the part to be vertical, and the cutout will work fine. The smart feature is attached to the part, so once you move it, rebuild, it will be updated automatically. So you can imagine for all the structure systems, for all the connection for your structure member, you can build your smart connection with all the holes, fasteners, and everything. And all you have to do is just drag and drop, and all the holes and fasteners will be applied automatically. And if you have any modification to modify the connection position, all the holes and fasteners will be updated automatically as well. Notice that all of this information now is stored inside this part. So this part must be in the library, and you will see here the smart feature and the smart component is attached to it in a folder called smart features. So you have to save this part with the assembly you used it to create the smart feature in the library to maintain the reference between them. Hopefully this topic was clear enough, and it's time for your question, guys.